Examples. Examples. Example 1. From the very document I sent you, I want to pick some examples. I know some people tried them out already, and I think that would be good enough for us to just use this time to confirm. Okay. Can someone rise up the hand and tell us the answer to Roman 1? Who is ready? Yes, Namanya, you can unmute.
The answer to Roman 1 is 1.
Is 1. Reason? Do you have a reason?
Yes, because the rule that says log a with the power with the index a, I'm confused about that, but log a is equal to 1.
When the base and the power are the same, the result is 1, not so?
Yes,
but it takes the rule of indices.
Yeah. Those using the chat to answer, that's wonderful. I see Joshua Younger says 1, Kate 1, Darren 1. Thank you. Let's go to Roman 2. Let's go to Roman 2. What do we say? Can someone tell us who is ready? Is ready? Is ready? Yes, Ayebale Zion, you can unmute. Ayebale Zion.
The answer is 2.
Take us through. How do you arrive to a 2?
Because we power 10 to power 2 to get 100.
Yes, that is after someone, possibly the side work is the prime factorization of 100 by 10, getting 1, meaning that 100 is the same as 10 squared. So you can write this as log of 10 squared to base 10 here, which becomes a 2 times the log of 10 base 10, which is actually 2 times 1, which implies that that result is equal to 2. Agree? Okay. That working I've been showing is very important. Let me hope someone has followed that up there. All right, let's see, get involved in yet another. I want to thank those substituting. Opio says 2, Keith 2, Joshua 2, Eric 2, Owen 2, Atrine, Darin, and Aaron. What part do you need to get the base? That is the question that we expect in someone's mind. So log of 1,000, what will we say? To the log of 1,000, what will we say? What should be? Who is ready to explain the log of 1,000? Who is ready? Yes or both? Yonan? You can raise up your hand when you wish to submit. Log of, yes, Benjamin Isaac, you can unmute.
Yes, sir.
So
we using your rule 3 to 10 in order to log the 1,000.
Yes. So 1,000 reduced by 10. This side work helps you to just confirm 1,000 reduced by 10. 1,000 is the same as 10 to the power 3. So this becomes deduced as log of 10 to the power 3 base 10. That would be the working. Then the 3 drops, I think people have been seeing that law. Then you leave this with a 10, 10, of which we know that this is 1, and the answer will be 3 at that instant. Yes, those that have submitted the 3, thank you. Thank you. Proceedingly, we can have another Roman 4, Roman 4, Roman 4 here, Roman 4 there. Can someone directly tell me what's the answer to Roman 4?
4.
Good. I see the answers coming in. But if it was a single-handed question, then you do handle it in the same way. Yes, the 4s are coming in. The 4s are coming in. That is good. And I believe someone has looked at as that 10,000 as 10 to the power 4. Then you get 4 times the log of 10 base 10, which gives us 4 times 1, and the result becomes 4 at that instant. We are building the concepts. We are building the concepts slowly, and I know we are getting there. I believe we are getting there. I believe we are getting there. Those who are not here, if someone can invite a friend who is missing, they better know that we are building a topic. They are missing the introduction, they will not like it as we go along. Roman 5. I'm looking at the chat. Let's submit Roman 5. Let's submit in the chat. Waiting for the first person to submit. Roman 5, Onyango Francis. Darwin is the first person with a 4. Onyango Francis a 4. Joshua Eyang says 8. Joel Erana says 4. Keith says 4. King Henry says 4. Eric Jonathan 4. Opio Arthur 4. Adrian Wafula 4. Abal 4. Rodin Stefan S says 4. That 4 comes about as a result of the candidate, first of all, prime factorizing the 16 by 2, which gives you 8 by 2 again. Someone gets a 4 by 2, 2 by 2, 1. And that sends us to saying that 16 is the same as a 2 to the power 4. That 16 can be looked at as a 2 to the power 4. As a 2 to the power 4. 2 to the power 4. From that statement, I can write that as log of 2 to power 4. That is to base 2. So when the 4 drops, it will be multiplied by log of 2 base 2, which is 1. So 4 times 1 is actually the same as just saying that whole statement takes us to 4. Very important ideas at this start. As we continue, what can we say as we continue? We start including some coefficients now. Look at Roman 6, submit in the chat. What's the answer to Roman 6? Submit in the chat. The answer to Roman 6. Who is submitting in the chat? Onyango Francis says it is 3. Let's submit. Onyango Francis has got a 3. Any other? Roman 6.
Also, we cannot see the number.
Are you sure? Roman 6 is a half log 64. Is my whiteboard clear, class? Do you see the whiteboard?
Yes, sir.
Yes,
Yes,
sir.
Yes.
Yes.
Yes, sir.
Now, how can we help that gentleman who is not seeing?
Let him leave and come back.
Yes, possibly.
Let him log out first, then he logs in.
If he's not seeing the whiteboard. Okay.
Cool.
I see 3, 3, 3, 3, 3, 3, 3. Okay. That is an expectation that people giving us a 3 have prime factorized the 64. When you prime factorize 64, what do you get? Can I have a hand?
Power 6.
Yes, I have a Zion has given himself the right to power 6. So that 64, when you prime factorize it, get 2 to power 6 base 2. So that a half will have a coefficient 6 multiplying the logarithm 2 base 2, which we know that log 2 to base 2 is 1. So that statement becomes a half times 6 times 1. So a half times 6 giving us a 3, and the half log of 64 to base 2 gives us a 3 at that instant. It gives us a 3 at that instant. Romans 7. Romans 7, log 125 to base 5. Can we send in the chat what it becomes? Log 125 base 5. Log 125 base 5. Fill the chat with the solutions. Log 125 base 5. The logarithm of 125 base 5. Can fill the chart with the solution. Three. Good. That's good. That's good. So that is upon the belief that 125 is 5 to power 3. That gives us 3, the log of 5 base 5, which is actually 3 times 1, which gives us a 3. That working, I've demonstrated it for purposes of not leaving out anyone. Next, that one, a third log of 7 to 9 base 3. A third log of 7 to 9 base 3. A third log of 7 to 9 base 3. A third log of 7 to 9 base 3. As someone computed that one, a third log of 7 to 9 base 3. Someone is getting it too. Someone is getting it too. that 729 should be prime factorized using that 3 for you to be safe. Use that 3 to prime factorize. 729. You can use the approach of the ladder. It's okay. You can use the approach of the ladder. It's okay. That approach, then you reduce that by 3, 729 by 3. I said 243.
It is 2.
243 by 3 again. You get an 81 by 3 again. That gives you a 27 by 3 again. I see a 9 by 3 again. 3, 3, then 1. So we notice that this is the same as a third, the log of 3 to the power 6 of base 3, which can be put down as 3 times 6 times log of 3 base 3. And that gives us a 2, because log 3 base 3 is 1. That ends us at a 2. So be keen, just have to be keen. Be keen with the presentation, or can't fail. You can't fail to get the answer. You can proceed if people are comfortable with that solution. We can proceed. So I want to confirm that evaluation has been understood. Just tell me the answer to this question here. That last part, then we go to more than one logarithm at a time. Just fill the chart. Log 81 base 3. What's the answer? Log 81 base 3. What's the answer? Rodriguez, about Rodin, Chiravo, King Henry, Roman, Brian Wafula, Aaron, Paul, Ayeva Zion, Boa Kevin, or Tie, Timothy, Isaac, Emmanuel, Chimera, good. It is a 4. The log of 81 base 3 is a 4. Thank you so much. Now, example number 2, that was example number 1, where we have been evaluating single logarithms. Example 2, I want us now to shift it to simplifying more than one logarithm at a time. Example 2, without using a calculator, simplify. Our Roman 1 is that. Can I have someone ready to take us through? Raise up the hand. Put up your hand if you're willing to take us through that first part.
Yes, sir. Me can.
Benjamin Isaac, you can tell us what's the next step there.
Since all the bases are the same, then we can remove them. We can just say log 40 plus log 50 minus log 20.
What do you mean? We can just say log of
40 plus log of 50 minus log of 20. Next is log 90 minus log 20.
Log 90 minus log 20. Were you around when we are introducing the topic? Have you been around at the start of the lesson?
Sir, me?
Okay, let me hear from Ayevale. People have something to say about your working. Yes, Zion, what do you say?
So following the rules, when the decimals are the same and we are adding, when we are subtracting, we divide.
Good. From the laws, when you say addition, so the first thing
We shall multiply 40 times 50 and then we divide.
Log 40 base 10 plus the log of 50 base 10. Bracket that off and keep the minus weighting. Keep the minus weighting. So in addition, the law suggests that when adding logs to the same base, you can write one single logarithm and then multiply those powers minus the log of 20 to the base 10. Are we at the same level? Do we agree with that?
Yes.
Yes.
Good. So from the laws, that becomes log. That becomes log of 4. Is that 200 or 2000?
2000.
Base 10 minus the log of 20 base 10. Now we are at a level when it's subtracting. We are at a point when it's subtracting. So what will be the next step? What will happen to log of 2000 minus log 20? Subtraction. The single logarithm will have which computation? Which operation will we have in the single logarithm now?
Log of 2000 divided by
out of 20.
Good. Log of 2000 out of 20.
divided by
Thank you.
20.
Thank you.
Yeah.
Log of 2000 out of 20. So someone who was not here at the beginning, you should be taking note of the laws we are applying here. And then next, we will have to write log. When you simplify that, remain with 100.
100.
Are we there? And that 100 can be the same as 10 squared base 10, which is the same as 2 log 10 base 10. But for us, we know that 2 log 10 base 10 is the same as 2 times 1, which actually can be denoted as a 2. Are we okay, members?
Yes, sir.
Yes, sir.
Yes, sir. What happened to log 20 out of 10?
I beg your pardon, the person who has just asked.
What happened to log 20 out of 10 minus log 20 out of 10?
Where is log of 20 out of 10?
The subtraction, what happened to it?
That person also missed the laws. When I beg, don't switch off your mic. I want us to help you. Don't switch off your mic. You are who?
Okay, sir. Mujuruzi.
Now, Mujuris, when it's subtracting logs, these two laws are the ones we are applying now. Log of A base X plus log of B base X can be put down as a single logarithm. That's what the law suggests. And in that single logarithm, you multiply these numbers, A and B, only and only if these bases have been the same. And the log of A base X minus the log of b base x can also be put down as a single logarithm to that base, but when subtracting, you divide those numbers. The leading one first divided by the other one. As a single logarithm, are you okay?
Yes.
Yeah, so that's what we have done. When you try now to connect this to our solution, let me hope it makes sense to you. Log of 2000 minus log of 20 base 10, it becomes log of 2000 divided by 20 in a single logarithm now. Is it okay with you, this?
Yes.
We can go to Roman 2.
Excuse me, sir.
Who is that?
Isaac.
Yes, Isaac.
Can a log be given with a number that's not completely divisible by the number given by the base given?
Yes.
Like for example,
yes, it's possible.
How do you work it out?
Don't worry, all will be well. For example, you wanted to suggest, for example, what?
14 to the base 3. Log 14 to the base 3.
Log of 14 to the base 3. And this is your last, and you have this as your last step. Is it what you want to suggest? That is,
yes,
suppose you have this as your last step.
Yes.
And you can't factorize 14 in terms of 3. Then you leave it as that. You just underline that. Suppose you land it to 14 base 3, where 14 can't be prime factorized in terms of 3. You just get your long ruler and underline that as your solution.
Oh, okay.
All right, next question. Next question. In line with evaluation, I want people to believe that this is a true log of 50 base 10 plus log 80 base 10 again minus 2 log 2 base 10. Can I have someone ready to submit by show of hands? Can I have someone ready to submit by show of hands? What is your name? You have switched on your mic. Yes, Titus, unmute. Let me take Titus. I have a Ziwe. Titus, you can unmute. Titus, you can unmute.
Yes, sir.
What should we say? This will be?
Just that.
We open brackets. 2 log 50 base 10 plus
2 log 50 base 10 plus
log 80 base 10 close brackets minus 2 log 2 base 10.
Good. Next.
Two log 50 base 10 time 2 log 50 times 80
base 10.
You're saying from here we should
Sir.
write 2 log 50 base 10.
There on it is 2 log 50 times 80 base 10.
Times 80, like this.
Yes, sir.
Now there's a problem there. Anyone to add to submit? Eric, Jonathan, do you have anything to say about Titus's submission?
I think we get 50, then we raise it to power 2 to base.
The first
this base 2.
Okay,
You get log 50 to power 2.
It should have been Titus. Titus, are you there?
Yes, sir.
Log 50 to power 2.
You would have been, first of all, ensuring that the coefficients are all the same. Those laws are true when the coefficients are the same. So that pushes the true up onto 50. Minus, don't wait, do the same to this one, waiting, that 2 squared, it becomes 2 squared base 10. Titus, is it okay?
Excuse me.
Yes, sir.
Excuse me, sir.
This one would be a wrong step.
Excuse me, sir.
Please.
Teacher, that log after the minus, in what I have, it doesn't have the 2 at the start.
Oh, it doesn't have a 2 at the start. You're right.
Yes.
Yeah, it doesn't have a 2 at the start. You're right. Yeah, thank you for that correction. Otherwise, have we got the trick, all of us, ensuring the coefficients are the same?
Yes, sir.
Yes, sir.
So we can
Yes, sir.
proceed. What shall we say then? Next. On the next step, what should we say?
Then you multiply. Get 50, you get the answer.
So what is 50 squared?
2,500.
That is now the log of 2,500 times 80 in one logarithm. Base 10 minus our log 2.
1,580 base 10.
What's that product
Base 10.
equal to? Has someone computed that product?
It's 20,000.
Pardon?
20,000.
200,000.
200,000. Yeah, it's 200,000.
Yes, minus the log of 2 base 10. What should be the next step there, class?
Find the log of 2.
That will be
0.3010.
That should be log of, the next step should be log of
200,000. 200,000. Divide by 2.
Thank you. Which you can finally write as
100,000.
Which we can finally write as
100,000.
Log 100,000.
Log of
100,000.
100,000 to base 10.
That
means us write log of 10 the power 5 base 10 comes a 5 log 10 base 10, which is 5. And we agree, class, with the 5?
Yes.
No.
Good.
Yes, sir.
Good. Next. Next question. Next question. Next question. You have those questions. Those that I skip, please do them. Let's fill your notes. As long as you follow the rules appropriately, fill up your notes. We have 4. Who is ready to submit? We have 4 log of 5 plus a half log of 64 minus a third log of 125. All to base 10. Writing it without a base keeps us in our minds that you're looking at base 10. Who is ready? Who is ready to take us through? Eric, Jonathan, you can unmute.
I think we get log 5 to power 4. The first relax. Plus log 64 to power half. We put the brackets. Minus log 125 to power third.
Next.
Then we go to the brackets and we say log 5 to power 4.
Log
which is
5 to the power 4 is
625. 625.
625 plus.
Forget. Okay. 64 to power 2 is well. No, neither. Then we get log to power log 8. Log 4.
Log.
What's that? 64.
Log.
8. It's 8. Then we put the brackets. Then 125 power third.
If someone is lost with a 64 power half, that person should know that 8 squared is 64 power half using indices. It is 2 times a half. So these 2's cancel out to give us that 8. What about 125 power third?
It will be then we get log 5.
That will give us log
25.
Log 5.
Log 5. Log 5. I have had someone say 25. When you prime factorize 125 by 5, you get 25 by 5, you get 5, then by 5 you get a 1, meaning 125 to power a third. In place of 125, we can substitute 5 to power 3, power a third. When these multiply, we get 1, which is 5. The person who is thinking of 25, please.
So then we multiply log 625 times 8.
The person who is looking at number 3, I've skipped it intentionally because they are just 2 terms, which I believe now you can handle. I believe now you can handle. Okay. Next.
We get log 625 times 8.
Log of 625 times 8. Also. Minus
Yes.
log
Minus
of 5.
5.
That question, that's right.
To be log 5,000.
Pardon?
Log 5,000.
Log of 5,000 minus log.
Minus log 5.
Which becomes?
We shall divide 5,000 divide by 5.
Which would be 1,000. Is it?
To base 10. Then we bring back the base.
Okay. You want the base back?
Yes, then we shall get to be 3 log 10 to power 10 to base 10. I shall get 3 log 10 to base 10.
Correct.
Then we shall get 3 times 1, which will equal to 3.
Thank you, Jonathan. That has been a perfect submission.
Welcome, sir.
I have some hands up. Someone was asking, I think. Sin, Namanya, are you asking?
Yes, teacher. Teacher, somewhere. Where did bases go? Like those things, where did they go? I'm lost.
A logarithm without a base. We did it intentionally. A logarithm without a base is base 10. If someone writes log A, that means that is log A to base 10. So you must have missed the introduction as well. If someone writes log of X without anything down here, that implies that is the same as log of X base 10. Understood?
Okay. Yes, teacher, I've understood.
Thank you. Thank you. All right. Next question. Next question. Want to brainstorm this idea today. I'm now making it. More. Let me go through a more a bit challenging problem. There we go. Those I leave out, I'm now comfortable that the people here can handle them. So we have a half. We have a half, the log of 16 to base 10 plus the log of a squared to the base 10 minus 2 the log of a over 5 base 10. Now there is an unknown value that is a, which we don't know. So I would of course start with saying 16 to the power half base 10 plus the log of a squared the base 10. And then I subtract off the log of a over 5, but all squared to the base 10. So now 16 squared. Can we use the chart? What will 16 squared become?
8.
8. 4.
That is
To the power 2, it's 4.
Oh, it's 4.
4.
thank you. That
4.
is 4 base 10 plus the log of s squared base 10 again minus the log of s squared over 25 base 10. Agree? Do we agree, class?
Excuse me, teacher. I thought that when we have a 2 outside a bracket, it multiplies both a and 5.
That's why it's 25.
Yes, that's why in the denominator we have 25. That becomes a power of that quantity. Then it distributes on each term s squared over 5 squared, which becomes s squared over 25.
Okay, teacher.
All right. So that
But teacher,
becomes, yes.
teacher, why did you choose to use why did you choose to find the square of 16 yet the log was a half?
I didn't square 16. I have
But
16 power half. That half becomes the power of 16. Then we write 16 as 4 squared to power half. But in indices,
okay.
then topic, those powers multiply. Agree?
Okay. Yes.
So that becomes now the log of 4 times s squared, if people do agree. 4 times s squared to base 10 minus the log of s squared over 25 base 10. Do we agree with that level where we are?
Yes. Yeah.
Yes, sir.
So that is the same as, what we have is the same as someone writing 4s squared to base 10 minus the log of s squared out of 25 base 10 again. Now, when subtracting, what are we going to do to those numbers?
Divide.
We are going to divide. We are going to divide. So when we divide, what do we get? We get log.
-2.
Someone can divide aside. Check 4s squared divided by s squared out of 25. What will happen? You can check it aside. That is the same as 4s squared times 25 out of s squared. Someone should notice that the s squared will cancel out, giving us with a 4 times the 25, which will be 100 base 10. Do we agree, class?
Yes, sir.
Yes, sir.
Good. I'm seeing someone talking about a -2.
Sir, I'm not getting.
That
So
person,
the answer is 2.
So I'm not understanding.
where have you got lost from?
How we have come to 100 out of 10.
Yes.
Maybe the reciprocal. Like,
what is going to happen is, let's do it in the logarithms for him. Those numbers are going to multiply. those numbers are going to divide since we are subtracting. This one must be divided by that one. Do you agree, Sebo?
Yes.
So we'll get 4s squared divided by s squared over 25 in one logarithm. And that becomes the log of base 10 over 4s squared times, we take the reciprocal as we change that sign, not so.
Yes.
25 over s squared. And that's what, and then that is the instant where I talked about this a and that a cancelling because it's
They'll cancel.
so you remain with the 4 times 25 there, which becomes what?
100. 100.
So that logarithm will now have become the log of 100 base 10. You now agree with 100
over 100,
which is 10 squared
yes,
base 10, which is the same as 2 log 10 base 10, which is the same as 2. Not so?
2 times 1, which is
2.
Are you okay, Sebo?
Yes, sir.
All right.
Sir, but how about the way you are multiplying the half?
What about what? There's someone with a question. I want to clear it.
The
What
half that
about
was the
what?
power.
Huh? What about what?
The half which was a power.
From where? Where are you lost? Which half are you talking about?
Select
Your mic.
log
Keep the
16.
mic on. Titus, which half?
Log 16 power a half base 10.
The second step there.
You are lost with the how data half disappeared.
Yes.
16 to power half. I wanted you to use the indices. Write 16 as in terms of 4. Which power will 4 have to be 16? 16 by 4, you get 4. By 4, 1. 4 squared is 16. Not so?
Yes, sir.
Then the powers multiply. 2 times a half. That 2 cancels, and 4 is the same as 16. Not so? Do you agree?
Yes, sir.
Do you agree?
Yes, sir.
That's how it changes. Eh?
Thank you, sir.
Can we have one more question?
Yes, sir.
All right. Let's have one more question as we end today's discussion of simplification. You may have a question with purely unknowns. For example, that one. For example, that one. They want us to simplify log a base a plus 2 log a base a minus the log of a to power negative 3 base a. They want us to simplify that. Are we there? Yes. I'm going to send this very work we have been using to discuss. These very submissions, they are the ones I'm going to share on WhatsApp immediately. Are you with me? I'm going to save it as
Yes, sir.
as S2. Let me do it even now. S2 logs body 1. S2 logs body 1. I will share it immediately. I'm going to send this board as a document. When you tap it, but it will be a photo. When you tap it, you will be able to zoom and slide it in different directions as you view the steps. Is it okay?
Yes, sir.
Yes, sir.
I'm going to drop it
Yes,
the
sir.
way it
Yes,
is.
sir. It's very.
I'm going to drop it in WhatsApp.
So, but how about the video?
How about that?
The video you're
Oh, even if after scanning it, I will post it on my channel and share with you the link.
Okay, sir.
okay, sir.
I have a channel. I will share with you the link.
Okay, sir.
Okay,
What's its
let's
name?
conclude. Let's conclude. Do we agree that this is the same as log? Someone can ignore the evaluation and first of all writes it as log S squared base A minus log A to power -3 base A. And this becomes log A times S squared base A minus the log of A to power -3 base A. Then the final step becomes, log S cubed base A minus log A power -3 base A. Since we are subtracting, we can then divide log A cubed divided by log A power -3 to the same base A. And we know that when dividing logs, we subtract the powers. So that will be log power 3 minus the -3 power in the denominator, which can be deduced as log of A to power 6 if someone is very careful, which you can write as 6 log A base A, and therefore that is automatically a 6 because A base A is 1. But I want to mention that that same question, you would do it. I want to mention that that same question, you would do it without, since they are all in terms of A candidate would do it by just evaluating. Of course, you remember that this is an alternative. You remember that log A base A is 1 plus 2. Log A base A is 1. Then minus that -3 can drop, and it leaves you with the log A base A, which is 1. So 1 plus 2 is 3. A negative, with that negative, we get a positive 3. Log A base A is 1, which still gives you 3 plus 3, which is a 6 as the same answer. So you can get the same answer since the question was looking at same quantities, though unknowns, but same quantities. Unless otherwise, I want to stop this here, and then I'll request that we complete all the questions in example in number 2. Complete all the questions in number 2. Complete number 1 and number 2 in that document I sent. Complete number 1 and number 2 with their respective parts. So in our next lesson, we will proceed to number 3. But if in the next lesson there are challenges in number 1 and number 2, we'll first of all tackle them and proceed accordingly. I want to thank you so much for being participative. Allow me pause our discussion here, and I wish you a nice week.
So